exciting. Okay? So please, next. Sure. Next. Okay. So some things about stars. The basic is the names of the stars. So very, very bright stars have names since times we don't even remember. But also, aside with the names of particular stars, they named the constellations, groups of stars, and that was helpful to, for example, have a calendar. So since the very past, people used to put names to the stars and to constellations to build a calendar, and that was helpful to become from nomads to citizens, to sedentary people. So that was helpful. And some names we still use come from the Greeks, some other names come from the Arabs, and some other cultures. And also in each particular country still are usable names from our own ancestors. So for example, in Mexico, we also have some stars named after our ancestors, Mexican ancestors. So that's something interesting. The observation of the stars was particularly developed, as I told you before, for agriculture or some other activities. But something that was very difficult to do was realize that stars are not at the same distances, all of them. In the very past, we used to think that stars were all like a sticker in a big sphere, but it was not like that. So people realized after a long time that some stars are closer to us, some stars are very far away. Next, please. Now, when scientific knowledge started to develop with many people, but mostly with Galileo Galilei and then Isaac Newton, some things were learned about the stars, like the luminosities, temperatures, which were something like if we know one star seems to be brighter than another star, maybe it's because this is bigger than this other one, or maybe it's because this is hotter than this, or maybe it's because this is closer than this. There are several reasons. So we have to learn what was that about. Is the luminosities, is the temperatures, it's something else? I wrote here spectral process because when Newton, for the first time, made pass light through a prism, maybe you remember this thing about having a prism and ray of light, and then after here we have several colors. So this was called a spectrum. So when studying the stars, someone at first made this. Let's make light pass through a prism and see the spectrum, and they realized that different stars have different spectra. So this was classified also like a spectrum class for several stars. And a very useful tool for astronomers is what we call the Hertzsprung-Russell diagram, which makes here like the luminosity here, the luminosity of a star, and then here the spectral class that we learn then after that is related with the temperature. So here we have very hot stars, and they are colder through here. Now, these stars are very fine and then are brighter and brighter. So most of the stars are accumulated in this line, which is called the main sequence. Most of them are in the main sequence, but some other are in some other regions accumulated. And this is the main tool for astronomers. From here we can infer many other things about the stars. Okay? Now next, please. Okay. Something interesting about stars is that very few are isolated, like our sun. Most of stars go in pairs, and many others are accumulated like here. So they form clusters, and some of them are open clusters, like this one. This maybe some of you know, this is very famous. It is called the Pleiades. And this is called a globular cluster. In an open cluster, we have hundreds of stars. In a globular cluster, we have like thousands or even millions of stars. So it's very different, not just by sight, but physically they are very different. Now, these clusters help us to understand the stars too, because if they are close to them, maybe some are just casually close, but most of them are physically united. They are united by gravity. So this and these other kind of clusters have different physical nature, and they help us to understand what is happening with those stars. Next, please. Thank you. So, what happens with the stars? Stars are born when this gas in a cloud starts attracting by gravity, and they contract. When they contract, some of them accumulate in spheres, and those spheres, after having contraction, they start heating, and when they are heating, after a while, they start doing nuclear reactions, and those nuclear reactions are those that start the star being a star instead of just a sphere of gas. To be a star, they have to do nuclear reactions and then produce energy, mostly like light, but some other forms of energy are liberated from the star. And so they start with a cloud, but then after they start doing reactions and they become stars. But when we see stuff like this, we know most of the stars around here are young stars. They just recently were born. And maybe in the future, more other stars are going to be born around here. Okay? So that's something we know. When we look at the sky and see different regions, we can see the different stages in the evolution of the stars. Okay, so next please. Oh my gosh, what happened? Okay, never mind.
You want me to go next one?
No, it's okay. I will, or whatever. Some stars are not, indeed many stars are not constant in light, but they vary. Now, the first thing people did was, of course, naming variable stars too. So, Okay, I told you before, some stars have their names since long time ago, but some others acquire new names. And one way, there are many, but one way of naming stars was this. When we see a constellation, like for example this, the brightest star is named after this constellation, for example, is Orion. So we abbreviate Ori, and the brightest star takes the first letter of the Greek alphabet. So it's Alpha Ori. The second brightest, of course, is going to be Beta Ori.
Mathematics.
What?
You're mathematician.
Okay, so, and then we name the stars after putting all the Greek letters, and then after we use some other kinds of names. Also, variable stars, for a weird reason, are like this. The first variable star discovered in Orion is named R Ori. The second is S Ori, etc., until we get to Seth. Then after, it started like R Ori, R S R T, etc., R Seth. Then S R, etc.
Too many stars.
Yes, then after we went to AA, etc. We skipped O for obvious reasons. This might be also 0, 0, so that's not this way. And then until we get to QZ. After this, the next star is named V. I don't know what the number is. Let's say it's 2, 3, 4, and etc. Okay. We name the stars like this. It's weird, but that's how it is. So many stars have 2, 3, or many other names. So, for example, Alpha Ori is also V347 Ori, I think, etc. So this is because it's the brightest star. This is because it's the number 347 variable star, etc. When new catalogs are built, they put some new names. Okay? So this is about naming variable stars. Next, please. Now. Okay. Some variable stars vary their bright because, as I told you before, many stars are double stars. So when as they are double stars, they have a rotation, translation around. And if this star is brighter than this, when it is behind this other star, we see less light, so we see it fainter. When this is like here, it's brighter, etc. If they are apart together, so it's brighter, etc. So we see variations in light because they are eclipsing each other. No, next, please. Also, some other are varying because the star itself is varying in size. So sometimes it's bigger, sometimes it's shorter. And what happens here? When a star is contracting, we see it brighter because it's hotter. When it expands, it becomes cooler, so we see it fainter. And the astronomer can measure this, which we call it the light curve of the star. And measuring the light curve, we can find many facts about it. So from here to here we have a period. Some stars have bigger periods, some others have shorter periods. And we can classify stars also because of the light curves. And we learn many other things about them. So please next. So, the age of the stars, as I told you, some stars are like recently born, and they are still close to a cloud of gas. Some others are very old. In the two clusters I showed you before, we have very young stars, and the other showed us very old stars. What do we learn about them? For example, if they are close to what I told you is the main sequence, some stars are not yet in the main sequence. They are still contracting. So when we construct a Hertzsprung-Russell diagram and we see stuff like this, we know that the stars around here are young. And on the other hand, when we see something like this, many stars are becoming giant stars, is because the stars in this cluster are very old stars. So what is happening? As I told you, stars have nuclear reactions inside. But in those reactions, what is happening is that okay, I didn't prepare that here, but I can explain here, it's okay. Most stars are formed mostly with hydrogen. The hydrogen, the lighter element. So they have hydrogen, but then nuclear reactions occur in the interior of the star, and when they find some other atoms, four nuclei of them form one nucleus alone of helium, another gas. And this reaction, this nuclear reaction, is called fusion. Okay. So when fusion occurs, hydrogen becomes helium, and this reaction is happening and liberating energy. When the energy is liberated, we, of course, we see light, but also we feel the heat, and many other kinds of energy are liberated. And someday, after millions of years, but at least it will eventually happen that all this gas became this gas. And the combustible inside the star is over. So that makes the star change. And the stars evolve becoming giant stars. Giant stars because when all this gas becomes helium, they have an explosion that makes star expand a lot, and they become giant stars. But they are finite, and they come to here. So all these stars are dying. When they become giant, they are becoming older and eventually will die. Before this happens, before they die, they have some activity like what I showed you before. They start burning. So that doesn't happen immediately, but in the middle they have variability. So that gives us a clue about their lives. When a star is variating, we know that star is not a young star, it's an old star, and maybe in the next 1 million years, it will become a giant star, and then after it will die. Okay, next please. Okay, oh my gosh. Okay. When I was doing this, I studied a cluster of stars. And I discovered, no, well, before, I found something weird. Because when studying an open cluster, I found two variable stars. So that was weird because, as I told you, stars start variating when they are old. But in an open cluster, they are supposed to be young stars. So what happened? When I was studying this, I found that the stars, the variable stars I was studying, were embedded inside the open cluster. And it was like this. They were around here, and we said, what is happening? It's like finding in the daycare center two old people sitting aside. What is the point? What is happening here? And what could have happened there? At first, we thought these two stars, two variable stars, were just, for example, the cluster was here, and the two variable stars, maybe they were closer or farther away, and we were just seeing like if they were inside the cluster. But it was a little difficult to find the distance. So we were studying all the stars around, and we found something interesting. We found that, let's say, we are watching from here, like here, and we have a cluster here with a lot of gas. And for a weird reason, some other stars were far away, our two variable stars, but also another cluster, another cluster. So we were watching two clusters in the same direction. And we discovered that this forms one group, this another group. The distance between them are very different. And these are old stars, these are young stars. And well, discovering this, I earned my degree.
Wow. Very good.
Good for you.
So,
Good job.
okay, so now it's over, right?
Yeah.
So now, do you have any questions?
What are the distances?
What?
What are the distances?
Yes, to here it was like around 500 parsecs, which is like 2,000 light years. And to here it was 850 parsecs, which is multiplied by 4. So
400
light years. In astronomy, we use mostly this unit, parsecs, which means in one unit of this we have an angle of one second. You know, degrees, minutes, seconds. and the parallax it's 1 second. So we use parsecs, parallax second. But mostly for other people, they use light years. Yes.
What kind of gas is in stars? What kind of gas?
Mostly hydrogen. Yes, it's the most abundant gas in the whole universe, hydrogen. So, is inside the stars that some other elements are formed, like not just helium, but some other elements are formed inside the stars. So, for example, the planets were formed, the elements in the planets were formed inside the stars, and when they were in the explosion, they were evicted. It's that they become planets or any other stuff.
So based on your talk, is it basic? You find out how old the stars are based on how bright it is. Is it correct? Like if it's brighter, you think that they're younger stars.
Not
they're
exactly.
not-
No. It's not just the bright. It is one of the things, but also we find the ages of the stars in groups.
In groups.
For isolated stars, it's difficult to know what is happening. We can know the ages of the stars in groups.
In groups.
Yes,
Okay.
because for isolated, it's almost impossible to know. Yeah. Yes.
What about the gravity when in this space? I don't understand exactly the gravity in the. You talked about one time gravity. The star sometimes gravitate.
Yes, gravity is what we call a central force.
Mhm.
So if we have anything around, they tend to attract each
Mhm.
other. So this attracts this, and this attracts this, etc. Yes, but it's we call it a central force, so everything is attracted to a center. And if, for example, this is heavier than the rest, this will attract the others. So when we have a cloud of gas, well, it is not, the gas is not uniformly distributed, of course. So if we have like a gas around here, but around here the density is bigger than the rest, all the other gas will feel attracted to here. So when they attract, the gas is around here, but then after it will become attracted to a center. And that it's attracted. But the attraction continues. But as the gas, when it is contracted, it is also hitting itself. So when it hits itself, it will, of course, start sending light. But then after, it is also getting hotter, until at a certain temperature, nuclear reactions start happening. So to contract the gravity, it's the main force. But then after, when this is heading, the nuclear reaction are the one that stabilizes this contraction. So there are two forces here, like competing, the attraction of gravity, but also the reactions that pull out with this energy generated here. So does that answer your
Yeah.
question?
Very specific answer, eh?
Okay. Yes.
So the sun,
Uh-huh.
what kind of materials inside there?
Mostly hydrogen. Also, in all stars, there are many other elements, of course. But in stars like the sun, I would say like 98%. It's high protein. In the very core, it is like 1% helium, and the other 1% are almost all the other elements. All the other elements, including, for example, gold. The sun has inside more gold than that in the earth. Unfortunately, we cannot get it. So all the other elements, almost all the other elements. Some elements are not in the sun. What elements? The ones that have radioactivity. So, for example, in the sun we cannot find uranium or plutonium.
Or lithium.
What?
Lithium.
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 Not the atom itself, but the nuclei. We can find nuclei of the lithium. Yeah. Plutonium and uranium. Yeah. Indeed, no, the heavier elements, those that even in the earth are difficult to find, and they don't last for a long time because the other kind of reaction I talked about fusion. The other, no, this is when light elements become heavy. But the other reaction is when very heavy elements, like these ones, are split in lighter elements. This is fission. And we cannot find these elements. Indeed, that's why in some laboratories they enforce to happen very heavy elements, and they last for seconds, and they disintegrate. Yeah, so.
Interesting.
Yeah.
Interesting.
Very interesting. Very well thought out.
See you later in YouTube.
Yeah, good. Well done.
Yeah, very good.